something that measures to the 4th decimal place, and it costs a lot more money. And the reason we spend that kind of money, we buy those equipment, is because we need that kind of accuracy. So, considering the amount of money we put out to buy those equipments there, and you better write down everything that the equipment is capable of telling you. And otherwise, we wouldn't really need to waste that kind of money on the equipment there. So always pay attention when you do measurements in the laboratory. Always pay attention to the devices that you're using, the instrument that you're using, and their accuracy. And make sure and especially important tomorrow when you go to the lab there, we are doing the water hydration lab. We're trying to determine the what we call a constant mass. When you get into the lab there, we'll talk about how we define constant mass. So we're looking for the differences on the 3rd decimal place for mass measurement, for consecutive mass measurements there. If you only write down 2 decimal places when you do your measurement, you may not even know what's the difference on the 3rd decimal place or even the 4th decimal place there. So it's very important that you always write down the correct number of decimal places. Well, whatever the equipment is capable of giving you, you always write them down, and because we need that kind of accuracy. Yeah. So we'll come back to the second half, and I'll probably do another 40 minutes, roughly about, we'll probably wrap this up around 10-ish, 10-15 the max. We'll start talking about chapter 3. Now we need to cover, and we have to use all the time that we're given for the summer class there to cover as much ground as we can. And the third exam, homework number 1 is due on Thursday when you take the first exam there. So as you can see, we are trying to finish chapter 3. Probably not today, but by tomorrow, the latest by Wednesday morning, the first half of Wednesday morning, we will definitely finish chapter 3. And then all of the homework questions assigned in chapter 3, you have to finish them, and you have to bring them in on Thursday when you take the exam. Okay. So in chapter 1 and chapter 2, chapter 1, we gave you a brief introduction about what chemistry is all about, what kind of calculations involved. In chapter 2, we introduced the periodic table. And at the end of chapter 2 there, we tried to emphasize the information given in the periodic table is just conversion factors that we can use when we do dimensional analysis. In chapter 1, I would say this over and over again. Chem 101, Chem 102, or even undergraduate level chemistry classes there. It's all about 2 things. Dimensional analysis, definition. Definition, you have to memorize it. Dimensional analysis, as long as you know how to identify the correct conversion factor, the calculation part is easy. So if you understand those 2 parts in chemistry, then chemistry is actually not that overwhelming or confusing or challenging. So those are the 2 things that you need to pay attention to. Now in chapter 3, we are going to look into molecules and compounds, and we gave you the alphabet. We told you how to spell the chemistry word. Now we need you to be able to write chemistry sentences, chemical equations there. And given a chemical reaction equation, we need you to be able to explain what that sentence means in plain English. Okay, so that's going to be the focus of chapter 3. Now in chapter 3, the first part, talking about molecules and compounds there's a lot of things going through the nomenclature. How do we name compounds? Now this is a very important part. However, when you go through those rules and the rules involved in nomenclature there, it's kind of dry. And when I look at my role in conducting this course there, I'm always trying to think of myself as a storyteller. And that is the part I still have yet to figure out how to make it more interesting instead of dry material there. So for that, I ask that you, when you take the time and read the textbook there, pay attention to the nomenclature rules there. How do we name compounds there? And you also need to memorize them. Okay, we're not going to get into the details about it, and I ask you to take the time and read through it. And again, for in-class exams, you will not be tested on the nomenclature. When I give you a compound, I'll give you the formula. When I use the name, I'll give you the formula. When I use the formula, I'll give you the name as well in exam questions. But 3 weeks or 5 weeks in the end, at the end of the semester, when you take the final exam there, you may see questions related to the nomenclature. So you do need to pay attention. Okay, so again, we separate chapter 3 into multiple smaller learning objectives there. And the first one is that we now need you to be able to recognize ionic molecular compounds from their formula. Now in chapter 2, we talked about there are only 3 possible combinations for ionic compound. That is metal, non-metal. You put them together, you get ionic compound. Okay, and when you have a metal and negative polyatomic ions, that's ionic compound. When you have positive polyatomic ions with no metal negative or negative polyatomic ions, you have ionic compounds there. So by looking at the formula, if you can recognize what is a metal, what is a non-metal, well, given the periodic table, that's easy. And if you can memorize all those 16, at least those 16 polyatomic ions there, then you will be able to determine, based on the formula present to you, whether a compound is ionic or molecular. Okay? And that's one of the things we need you to be able to recognize. And again, this is like learning a foreign language there. We give you the alphabet, and you have different spellings of the word there. You have to be able to differentiate what each word means, what category of each word is in, whether they're ionic or molecular. We also need you to be able to recognize and define different types of formulas that we introduce. We have what we call empirical formula, molecular formula, structural formula. 3 different types of formulas that we will introduce there. And you need to know their similarity, you need to know their difference there. Okay? And given the name of an ionic or molecular compound there, be able to write out the formula, or the other way around, giving you the formula to be able to write out the name of it. So again, this part is one of the learning objectives there, and I will not test you on this part. Rather, I want to give you some time, not a whole lot. I want to give you some time going through the material in the textbook. We have the PowerPoint slides in this particular part of the lecture there, and also the details are given in the textbook there. I want you to spend a little bit extra time and go through those nomenclature rules there. Try to memorize as much as you can. Okay? And talking about the compounds and elements there, now elements combine with each other to form compounds. So when you're given a periodic table, you have 118 elements there. And different elements will react differently, and you end up with different types of combinations. The combination is, the number of possible combinations is astronomical. We have many different types of compounds in this world, and every single one of them is made up of a particular element out of one of those 118 elements in there. So example for hydrogen, oxygen, and water. Okay, they are different. Elements and compounds are different. Okay, so in this case, if you have hydrogen, hydrogen is a gas. If you have oxygen, oxygen is a gas. Water is a liquid. Okay, so hydrogen atom or hydrogen molecules in this case. Okay, so versus oxygen molecules there. Now they are quite different from the compound that they can form. Okay, so if you look at the density, you look at the physical state at room temperature. Hydrogen is a gas, oxygen is a gas, water is a liquid. The boiling point are quite different. Okay, and the flammability. Water is something that you can use to put out most of the fires. I say most of the fire because sometimes the water can actually react with alkaline metal. So if sodium metal is on fire, you don't want to pour water to it. You're making things even worse because water reacts with sodium metal and actually generate hydrogen gas. Hydrogen gas becomes explosive there. So most of the time you can use water to put out fire. Okay, so in terms of flammability,